Hey there, it's Max. This is the 6th rendition of the Spokane Cyber Cup, and we're going through the final challenge of the slide rule series. In the previous challenges, we learned how to do multiplication and division, and now we're going to put all of those together to do a little cipher on a slide rule. So, we'll read the prompt. I've made a little cipher. The algorithm is C equals P times K mod 26, where C is the result, P is the input byte, and K is the key. Each letter in the alphabet is assigned a number from 0 to 25, with A being 0 and Z being 25. Our key will be 7. So, for instance, G, numerically 6, will be 7 times 6 mod 26. And that equals 16, and 16 is equal to Q in this context. So the challenge is to encrypt the text I am him using a slide rule. For each step, we need to do the following. Multiply P times K, which K is always going to be 7 in this context. We're going to do we're going to divide that by 26. Calculate the leftovers on paper or in your head of that division, and then convert the number to a letter. And if you do that for all of them, you'll end up getting the flag. So I is the first letter we need to do. If we do something in Python, we can see that this is going to be at index 8. So that's the number we actually want to start with. If we go to our slide rule, that means we need to do 7 times 8. So we're going to do multiplication. If we try to do 7 times 8 regularly, it's going to fail because it's going to overflow. So what we need to do is we need to do the other strategy for multiplication, the wrapping one. So we're going to do 7, and then we need to go to 8 on the scale, and that puts us at somewhere between 5 and 6. 5.5 and 5.6. That makes sense. 556 is what 7 times 8 is. So for I equals 7 or 8 times 7. And now we need to divide this by 26. So divided by 26 is what we need to do now. So 56 divided by 26. Is that going to underflow? I think it will. So we need to find 5.6 on here. So we need to line up the 5 or the 2.6 on top of the 56 that we have. So if we look at the C scale, we have about 2.5, which means this is probably 2.6 right here. So we're going to line up the 2.6 on the 5.6. And now if we go over here, we'll see that it's about 2. Which are about 20. Sorry, we have to consider all of the decimals and stuff here. Or is it about 2? No, it should be about 2. Yeah, it should be about 2. It's not 20. It's about 2 because we're taking two numbers that are of the same capacity. So that's fine. So we're at about 2. So we can say this is approximately, I don't know how to do that and quickly. So it's about 2. So what's the leftovers of this? We don't have a good way in the slide rule to do this, but we know that it is 26 times 2 is 52. And then we have, and we're dividing by 56, which means the leftover is 4. So what is 4 going to be? 4 is going to be D, I believe. Oh, no, it's E. You're right. That is E because it's 0, 1, 2, 3, 4. So we're counting with indexes in this case. So 4 is going to be E. And if you look, that is what the first one is. So we just do this process over and over and over again until we get the flag out. You'll notice that there are actually duplicated letters because it's a really simple substitution cipher because we have the same keys. So you'll notice that the I and I am and then the I and him actually have the same letter. One thing that's nice is there's some duplication here, so students don't have to do a ludicrous amount of work. So to recap, the students need to understand this cipher and then do the math in order to solve it. For part 1, they need to do the multiplication of 7 times the numerical value that we're using for the character. After that, they need to do the result of that divided by 26. Once they've done that, they should have a value that is correct. And it'll be some number, and we'll round down. So if it's 2.5, we round down to 2. At that point, we need to calculate the remainder. The remainder is the result of our cipher. So I hope this is a really fun series. I was really excited to do this. I think slide rules are super duper awesome, and I get why they got replaced, but it is interesting understanding the technology and the history of stuff. I think I said this in the beginning, but a lot of hacking is picking up stuff really quickly. I think this is a good way to practice it. So thanks for watching.